This week in CIST 2612, for Chapter 6, we're going to look at current digital forensic tools. The objectives of this chapter is to explain how to evaluate needs for digital forensics tools, describe available digital forensics software tools. We will list some considerations for digital forensics hardware tools, and also describe the methods for validating and testing forensics tools. When you're evaluating digital forensic tool needs, you should look for software that is versatile, flexible, and robust. Open source tools is something you may want to consider as an option because your goal is going to be to find the best value that has as many features as possible. So some questions to ask when evaluating tools. Some of the characteristics of the tools. You should look at what operating system does the forensic tool run. Is the tool versatile? What is the supported file system? Can the tool analyze more than one file system? Can a scripting language be used with a tool that can automate repetitive functions and tasks? Does it have an automated feature? And also, what is the vendor's reputation for providing product support? There are going to be two major categories of forensic tools. You're going to have hardware forensic tools and software forensic tools. Hardware forensic tools, they're going to range from simple single-purpose components to complete computer systems and servers. While the software forensic tools, they've got different types on these. They have either your command line applications or a GUI applications. And they're commonly going to be used to copy data from a suspect's disk drive to an image file. The computer forensics tool testing, that's a project that was sponsored by the National Institute of Standards and Technology to manage resource on digital forensics tools. You need to follow the guidelines set up by the NIST's CFTT program. And also look at the iOS standards. These may be helpful by following these guidelines. For example, iOS standard 27037, it states that digital forensic evidence first responders should use validated tools. Our digital forensic tools functions, that's going to break down into 5 different major categories. You have acquisition, validation and verification, extraction, reconstruction, and reporting. All right, acquisition, that is making a copy of the original drive. And like I've said, it's one of the 5 required functions of digital forensic tools. Now, it does have some sub-functions in the acquisition: physical data copying, logical data copying, data acquisition format, command line acquisition, GUI acquisition, and also remote live and memory acquisition. Those are sub-functions of the acquisition function for a tool. Now, you have 2 types of data copying methods used in software acquisition. You have physical copying of the entire drive or logical copying of a disk partition. Now, the formats for disk acquisition are vary from raw data to vendor-specific proprietary data. You can view the contents of raw image files with any hexadecimal editor. Creating smaller segment files is a typical feature found in vendor acquisition tools. The remote acquisition of files is common in larger organizations, and there are popular tools such as Access Data or Encase that allow you to do remote acquisitions of forensic drive images on a network. Another function of digital forensic tools is validation and verification. Our validation is confirming that the tool is functioning as intended. Verification is proving that two sets of data are identical by calculating hash values or using another similar method. A related process, this is also called filtering. That involves sorting and searching through the investigation findings to separate good data from suspicious data. Now, some subfunctions of validation and verification include hashing, filtering, and also analyzing the file headers, which is it discriminates files based on their types. The National Software Reference Library, they have compiled a list of known file hashes, and they've got these for a variety of operating systems, applications, and images. The NSRL, that's an NIST project. It has the goal of collecting all known hash values for commercial software and operating system files. Now, many digital forensic programs include a list of common header values. Okay, so with this information, you can see whether a file extension is incorrect for that file type. And many forensic tools will be able to identify the header values. Okay, extraction, that represents the recovery task in a digital investigation. This is something that's going to be the most challenging of all the tasks to master. Recovering the data is the first step in analyzing an investigation's data. Subfunctions of extractions includes data viewing, keyword searching, decompressing or uncompressing, carving, decrypting, bookmarking, and tagging. Keywords searches will help speed up the analysis for investigators. It's a method of filtering or finding file or other information by entering relevant characters, words, phrases in a search tool. Now, when you're looking at it from an investigative perspective, encrypted files and systems can be a problem. Many password recovery tools have a feature for generating potential password lists for a password dictionary attack. If the password dictionary attack fails, you can then run a brute force attack on the encrypted file. Brute force attack, that's a process of trying every combination of characters, letters, numbers, special characters that can be typically found on the keyboard to find a matching password or passphrase that can be used for the encrypted file. The password dictionary attack, that's an attack that uses a collection of words or phrases that might be passwords for an encrypted file. Password recovery programs, they can use a password dictionary, and it compares potential passwords for the encrypted file's password or passphrase hash value. Reconstruction, that's the process of rebuilding data files. This is one of the required functions of a digital forensics tool. Like I said, it recreates a suspect's drive to show what happens during a crime or incident. You have some methods to recreate the suspect's drive. You should include disk to disk copy, partition to partition copy, image to disk copy, image to partition copy, disk to image copy, rebuilding the files from data runs and carvings. To recreate an image suspect's drive, you will copy an image to another location. whether it's a partition, a physical drive, virtual machine. And the simplest method of this is to just use it as usual tool to make the direct disk to image copy. So we see some examples of disk to image copying. You can use a Linux DD command, Pro Discover Tools, Voom Technology Shadow Drive. Now, to complete a forensic disk analysis and examination, you need to create a report. The reporting has to perform a you need to know how to use the forensic tools login reports, generating capabilities. So it's going to produce a final report of your forensics investigation. The subfunctions of reporting include bookmarking or tagging, log reports, timelines, and then a report generator. They use this to produce the final report of your investigation. Now, some other considerations for your tools: consider the flexibility, reliability, future expandability of your tools. You want to create a software library with older versions of forensic utilities, operating systems, other programs. Just because something may be considered obsolete doesn't mean that you will not use it. So now we're going to look at sections to explore some options for command line and GUI tools in Windows and Linux. We'll start off looking at some command line forensics tools. Now, some of the first tools used that analyzed and extracted data from floppy disk and hard disk were MS-DOS tools for the IBM PC file systems. You also had Norton Disk Edit, and that was one of the first MS-DOS tools used for computer investigations. Now, one of the advantages is using the command line tools, they require a few system resources because they're designed to run in minimal configurations. So looking at some Linux tools, Unix has been mostly replaced by Linux, and it's gaining popularity due to the cost and the GUI features. Some of the Linux forensics tools are Smart, Helix 3, Kali Linux, Autopsy with Sleuth Kit, ForcePoint Threat Protection. Now, Smart, it was designed to be installed on numerous Linux versions, and with that you can analyze a variety of file systems, and there also have a number of plugin utilities that are included with Smart, and you can also use the Hex Viewer as one of the options in Smart. Helix 3. Helix is one of the easiest suites to begin with. You can load it on a live Windows system, and it loads as a bootable Linux operating system from a cold boot. Now we'll see here that some international courts have not accepted live acquisitions as a valid forensic practice yet. Kali Linux, it was formerly known as Backtrack. It includes a variety of tools, and it's got an easy-to-use KDE interface. Sleuth Kit is a Linux forensic tool. Autopsy was the browser interface used to access the Sleuth Kit's tools. We'll go over those in the next chapter. ForcePoint Threat Protection was formerly known as Second Look. It's a Linux memory analysis tool that was developed under a grant from the Air Force Research Lab for Pikeworks Corporation. And it was designed to do both on-site and remote memory acquisitions, and it can determine whether malware is present. Now, GUI forensic tools simplify digital forensic investigations and help training beginning investigators. Most of these are going to come in forms suites of tools. The advantages of using a GUI forensic tool: they are easy to use, they have the ability to multitask, and there's no need for learning older operating systems. We do have some disadvantages of using GUI forensic tools. You may have excessive resource requirements. They may produce inconsistent results. They can also create tool dependencies, where the investigator may only want to use the one tool that they know. And in that case, investigators should be familiar with more than one type of tool. Now the GUI forensic tools, they're no different from other GUI tools when they're compared with their equivalent command line utilities. Now, hardware is going to fail. Technology changes rapidly. Hardware is going to fail. You need to schedule equipment replacements periodically. You should consider the cost when planning your budget, including the failures, the maintenance fees, anticipated replacements, the amount of time that the forensic workstation will be running. When considering forensic workstations, you need to carefully consider what you need. So what type of workstation we need? Do you need it to be stationary, portable, or lightweight? You need to balance what you need with what your system can handle. So I want you to remember that RAM and storage need updating as technology advances. Now, the difference in planning the hardware for a digital forensic lab for a police agency or a private lab corporation, the police options, police agency labs, they need many options and use several PC configurations. So they will also need to keep a library in addition to the software library, the hardware library. The private corporation labs, they only handle one type of system in that organization. So they're going to deal with fewer options than the police labs. They'll deal with the known operating systems, known hardware, where the police agency will have multiple operating systems that they may have to deal with, or multiple types of hardware. Now, when you're building your forensics workstation, it's not as difficult as it sounds. There are some advantages to building your own forensics. You can customize this forensic workstation to your needs and also help you save money. Disadvantages to building your own forensic workstation: it can be hard to find support for problems. It can also be expensive if you're careless with your choices. You also need to identify what you intend to analyze. Now, if you buy a forensic workstation from a vendor as an alternative to this, you can buy these. You can something such as a FRED unit for digital intelligence, hardware mounts for PC, forensic PC. This can also give you vendor support, which can save you a lot of time and frustration when you have problems. You can also mix and match components to get the capabilities you need for your forensic workstation. All right, a write blocker is a hardware device or software program that prevents a computer from writing data to an evidence drive. That software is going to block. Software write blockers typically run in a shell mode. Hardware options are ideal for GUI forensic tools. They're going to act as a bridge between the suspect's drive and the forensic workstation. Now, when you use a write blocker, you can navigate to the blocked drive with any application, but you cannot write to that drive. A write blocker discards the written data. However, the operating system for that data is successfully copied. Or, excuse me, for the operating system, the data copy is successful. Now, some of the technologies, connected technologies that are used by write blockers, they include FireWire, USB 2, 3, SATA, PATA, and SCSI controllers. Now, you should determine where your data acquisition should take place when you're looking at a forensic workstation. Some of the recommendations for a forensic workstation include data acquisition techniques, such as USB 3.0 or FireWire, which you can acquire data easily with FireWire or USB write blocking devices. Uses a digital intelligence fire chief and laptop computer. Now, if you want to reduce hardware to carry, the WebTech forensic drive dock, and with this regular drive dock, FireWire bridge or Logic Cube Talon can be used. Some recommendations when choosing stationary or lightweight workstation: a full tower to allow expansion devices, as much memory and process power as your budget will allow. Also have different sizes of hard drives. You want a 400 watt or better power supply with a battery backup, external power, external FireWire and USB ports, assortment of drive adapter bridges, keyboard and mouse, good video card, with at least a 17-inch monitor, or maybe you need a high-end video card with dual monitors. Now, if you have a limited budget, one of the options may be outfitting your lab is to use a high-end gaming PC. It's very important to make sure your evidence that you recover and analyze can be admitted into court. So you want to preserve the integrity of your evidence. So you must test and validate your software to prevent damaging the evidence. So the National Institute of Standards and Technologies tools, they publish articles providing tools, and they create the procedures for testing and validating forensic software. The NIST has created criteria for testing forensic tools based on standard testing methods. ISO 17025, criteria for testing items that have no current standards. Now, your lab must meet these following criteria and keep accurate records. Category requirements, develop test assertions, identify test cases, establish a test method, and report test results. iOS 5725 and it's going to specify results must be repeatable and reproducible. The National Software Reference Library, this project, as we said, the goal is to collect all known hash values for commercial software and operating system files. It uses the SHA-1 to generate a known set of digital signatures. This is what we call the reference data set. Now you want to make sure that you use different tools. You use at least 2 different tools in there. One tool is going to be used for retrieving and examining your evidence. The other tool is going to be used for verifying your results. So you must understand how forensic tools work. Now, one way you can compare your results and verify a new tool is by using a disk editor, such as the Hex Workshop or WinHex. The disk editors, they don't have a flashy interface, but they are reliable tools and they can access raw data. One of the digital forensics examination protocols, you want to perform the investigation with a GUI tool, verify your results with a disk editor, and then compare the hash values obtained with both tools. Now, the protocol for when you want to report the problem to the tool vendor, and it's very important that you do not use that forensic tool until the problem has been fixed. You want to use a test hard drive for validation purposes. And do your research. Check the web for new additions, updates, patches, and validation tests for your tools. All right, so that's going to take us to the end of Chapter 6 for CIST 2612 Computer Forensics.